This is a video about writing ionic formulas. Um, so starting off in the notes here, I'm assuming that you guys either have access to an ion sheet or ions in your book, or you have them memorized or something like that. So based on that, if you want to look up ions before I do any type of problem, just pause the video quick and then we'll continue, and then unpause it and check to see your answer. Okay, ions. Obviously, they're atoms that have lost or gained electrons. So a cation is anything that has lost electrons, so therefore it's positive. An anion is anything that has gained electrons, therefore it's negative. Now, cations, just as a little tip here, tend to be metals. Not tend to be, metals become cations. And then the nonmetals will at least become our monatomic anions. Okay, so I just mentioned the word monatomic. Monatomic. Actually, mono means one. So these are single atom ions, and there's some examples there: Fe2 plus, Na plus, Cl minus, and so on. Polyatomic is anything that has more than one element, or an ion that has more than one element. And again, those are some examples there. Okay, next. Writing ionic formulas. As I mentioned in class, you are going to do this the vast majority of times. Okay, so any time that you are going to be approaching or coming across some type of formula, it's probably going to be ionic. So we want to spend a lot of time on this, and that's what this video is for. A couple things that I mentioned here: a formula is a ratio between these elements, and if you have a binary compound, it's easy to see this ratio. The binary, of course, means anything that has just two elements, one cation and one anion, and so on. Now, these rules actually come out of a Flynn lab, and the rules are excellent. You follow these 5 rules, and you're probably going to be set for how to do these ionic formulas. And there's a couple nuances there that I need to introduce to you guys, but for the most part, this is it. Cations are first, anions are written second, so just be careful of that. One of the most important rules here is this second rule, where the sum of the charges must equal 0. So you need the charges, the pluses, to equal the minuses. Okay, if you can do that, then you can write ionic formulas. Subscripts are used to indicate the amounts of ions. So we never write superscripts when we write a final formula. Number 4, you're going to use parentheses when to indicate multiple polyatomic ions. So on your ion sheets or on your book or wherever you're referencing these polyatomic ions, if you ever need more than one, you have to put it in parentheses, and you put the subscript 2 or 3 or 4 or however many you need outside of it to the right. And I'll show you guys that. And of course, since it's a ratio, we don't want to write charges in the final formula. We just want to write the regular subscripts, so we won't see any superscripts or any charges. Okay? All right, next, let's just practice some of these. All right, if we take a look at potassium fluoride, what you need to do is, I'm going to do these things. I'm just going to go through them. If you want to pause the video here and come up with all the answers, then check answers to what I do, that's probably the best thing to do. All right, with potassium fluoride, potassium is K+, fluoride is F-. So here I have +1, here I have -1, so those charges equal each other, so that's just Kf. Okay, now let's move on to aluminum nitride here. Oops, aluminum is Al3+, nitride is N3-, so I have 3 pluses here, I have 3 minuses here, those equal each other, so I'm going to use one of each, so I have AlN. Okay, moving down here to calcium bromide, this one's a little bit different. If I have calcium, which is 2+, and bromide, which is 1-, I notice I have 2 pluses here, but I only have 1- here, so I need to use another bromide. So now I have 2 pluses, now I have collectively 2 minuses here and here, so I have 1 Ca, and I don't need to write a subscript 1, I just assume that it's there. And then I have Br, but I used 1, 2, so I put a 2 there, and there's my final answer. Okay? Let's move down to strontium oxide. This one's also somewhat of an easy one, because when I take a look at strontium, it's 2+, and oxide's 2-. Here I have 2 pluses, here I have 2 minuses, so therefore they equal each other out. I use one of each, Sr1O1. Typically, you don't say the ones. I'm going to save aluminum oxide for last, and then I'm going to go down here to lithium phosphide. Lithium's +1 and phosphide's 3-. So I have +1 and 3 minuses, so I need to use 2 more lithiums. So I have 1, 2, 3 lithium, so I have Li3, and then I just have the 1 phosphide, so P1. And there's your answer. All right, aluminum oxide, a little bit different, a little bit more challenging. If I have Al and I have 3 plus and I have oxide which has 2 minus, I notice that 2 and 3 don't really go into one another like the other ones did. So what I'm going to do is use the lowest whole number that they both go into, and that's 6. So I need to get +6 and I need to get -6. So Al is 3 plus, so there's my +6 total. And I need to use, that's a couple more of these oxides, so there's -6. So I used 1, 2 Als, Al2, and I used 1, 2, 3 oxides, so O3. And there's your final answer. Okay? So that's a little bit of an introduction to writing these formulas here. Okay, some easy ones. Let's move on. On your ion sheet, you're going to see Roman numerals. And the Roman numerals are very, very simple. All the Roman numeral does is indicate the charge. Now, these are typically going to be transition metals or transition elements. The transition metals have multiple charges to them, so we have to distinguish which one is which. So you'll notice this can't be iron oxide and this can't be iron oxide because they're obviously two different things. This is going to be iron 2 oxide, and this is going to be iron 3 oxide. So we'll look into what that means here in a second. So the charge is indicated by the Roman numerals. That makes it real easy. You don't even have to look these up. Iron 3 is going to be Fe3+. Lead 2 is going to be Pb2+. Chromium 2 is going to be Cr2+. And lead 4 is Pb4+. So just be careful when you're using these things that you know exactly what you're doing when you're doing these. I think we're going to practice some on the next slide. Yes, here we go. Iron 2 chloride. So iron 2 must be Fe2+, and chloride must be Cl- when you look that up. So if I'm going to do that, I need a couple of Cl minuses. So I have 1 Fe, and I have 2 Cls, FeCl2. Okay, lead 4 nitride. Lead 4, oh, this one might be a little bit tougher. Pb4+ and nitride is 3-. So what number does 4 and 3 both go into? The lowest one, that's 12. So I'm going to need a couple of Pb4+s for a total of 3. And then I need 3 more nitrides. So I have Pb3 and N4. Now, let me point something out on this one. You'll notice that it's lead 4. Lead 4. And when I look at this formula here, I notice that the charge on the lead is actually sitting right here. So this is lead 4 nitride. Okay? So something to keep in mind there. All right, chromium 3 sulfide. Chromium is Cr3+ because it's chromium 3, and sulfide, when you look that up, is 2-. So the final answer here, once you get everything all worked out, is Cr2s3, and there's the charge on the chromium 3 sitting right there. Okay? So that's the Roman numerals. Just be careful with those. You must get used to using them, and when in doubt, just look it up. You guys obviously know that for my class, I don't require you to memorize the ions, so look it up. All right, next. Using polyatomic ions. Big bold face, yellow words here. Use parentheses around multiple polyatomic ions. This is what I always try to stress to you guys. So you have to use parentheses. So when you're doing these things, you have lithium nitrate. Lithium's +1. Nitrate is NO3 with a -1, and I just looked that up real quick. LiNO3. No big deal. No parentheses because I only have one nitrate, so just be careful. You do not need to use parentheses when you only have one polyatomic ion. Now check out this one. We have iron, which is 2+, and sulfate, which is 2-. So I have one of these to give me 2+. One of these gives me 2-, so the 2 pluses equal out the 2 minuses. This is, again, just FeSO4. Since I only needed one, I do not use parentheses. But if we take a look at this one down here, magnesium nitrate, Mg is 2+. Nitrate is NO2, careful, with a minus charge. So I need to use 2 nitrites. So this is going to be Mg NO2, 2. So I needed 2 of those, so I keep the NO2. Don't forget, and nitrite is NO2, so don't change that. One that always gets you guys in trouble is the lead is hydroxide. Lead 4 is obviously 4 plus. Hydroxide is OH minus. And when I have lead 4, obviously I need 4 of these hydroxides. So, geez, I'm just butchering this. But anyway, there's 4 of those there. So I need Pb. OH is polyatomic. Put it in parentheses and put a 4 outside. Okay, PbOH4 is how you would read that. Okay, next. Here's some more examples. Ammonium oxalate. Ammonium is NH4 plus. Oxalate is C2O4, 2 minus. So in this case, I need 2 NH4 pluses to cancel out the 2 minuses. So I have NH4, 2, C2O4. Okay? Again, pause this video anywhere you need to just to make sure that you're getting the right answer. Let's try the next one. Chromium 3 arsenate. Chromium 3 is Cr3 plus. Arsenate is ASO4 3 minus. So I have 1-to-1 ratio of the charges. So I have Cr ASO4, and that's done. Going back to ammonium here, ammonium nitrate, NH4 is +1 and nitrate is NO3 minus. I have a 1-to-1 relationship here with the charges, so I just need one of them, and you'll notice they do not get parentheses because I only need one of each. Okay, so a quick little note, ammonium is considered by most to be the only common polyatomic cation. So you won't approach too many of these cations that are polyatomic. Okay, what else do we got here? All right, naming ionic formulas. When you name ionic formulas, we're going to keep this real simple. If it's a metallic monatomic ion, just keep the name the same and just read it off the sheet. So metallic monatomic ions are exactly the same. Non-metallic monatomic ions, you're going to drop the ending and add "ide." So some of these things, some examples are nitrogen would be nitride, oxygen would be oxide, sulfur would be sulfide, chlorine would be chloride. You get the idea. If you ever have a polyatomic ion, you're going to look it up and just be careful of the Roman numerals when you're talking about the cations. Okay? So some examples of these. If we have to name this, and again, pause the video whenever you need to, but you're just going to say barium chloride. So this is barium chloride. This is strontium nitride. Sodium sulfate. Magnesium nitrate. Okay, up here we have ammonium. Notice I am not concerned with the subscripts. I'm just naming this. Forget about that. Phosphate. Okay, now be careful. This is chromium. Chromium has a Roman numeral. So I got to determine what the name of this is going to be based on what the charges are going to be. All right, so chromium could have several different things here. Now remember, oxide can only be -2. Chromium could be +2 or +3. Well, if I have a 2-to-3 ratio, it can't be 2-to-2. So I'm going to get rid of the 2. It's got to be a 3 there. So the 3 actually is right there, and the 2 is actually right there. So this is chromium 3 oxide. Okay, again, another example here. This could be copper 1 or it could be copper 2. Well, I need 2 of these. This always has a -1 charge, and I only need 1 of these. So the 1 goes right here, and this must be a 2 charge right here because of the 2 right there. So get rid of that 1. This has to be copper 2 hydroxide. Hydroxide. All right, this last one, for the reasons that I just described, is vanadium, but it has a Roman numeral, so just be careful. Vanadium 4 chloride. Okay. Next, let's see what else we got. Some more examples. Very quickly, this is zinc, hydrogen. There's no Roman numeral on zinc. Sulfate. Again, I'm just looking these up on the sheet. This is kind of a challenge. This is going to be lead 4 perchlorate. This one is going to be, now this one's especially a challenge. Okay, now here's the thing. Oxide can only be -2. Lead could be +2 or +4. When I look at the ratio, it's a 1-to-2 ratio. So I need a 1-to-2 ratio. The ratio here is 4-to-2 gives me the 1-to-2 ratio. I can't be using this or else it would be a 1-to-1 ratio. I need a 4-to-2 ratio, so it gives me 2-to-1. So this is going to be lead 4 oxide. Just be careful. That's the most tricky I can get. That's a tough one. And this is going to be copper 2 sulfide. And why is it copper 2 sulfide? Copper can be +1 or +2. I think it can even be +3. I'm not even sure about that. This can only be -2. So I got to use the ratio that gives me a 1-to-1 relationship because this is a 1-to-1 relationship. So get rid of the 1. It's going to be 1-to-1. Okay? All right. That's it as far as writing ionic formulas go. You got any questions? We're going to do, come see me. We're going to do plenty of practice on this stuff. All right?